Okay, hello everybody. So let S be the sector of a circle, whatever that is, of radius 2, centered at the origin, that's above the x-axis and below the line y equals x. Okay, so need to draw a picture before I even read anything else. Okay. So here's a circle of radius 2. Well, then that means that this point is 2 comma 0. And then here's the line y equals x. Well, okay, the circle would continue, right, down. But here's the line y equals x. And so that'll hit this circle at the point, I guess, normally I would think root 2 over 2, root 2 over 2. But then I have to remember that this circle has radius 2. So I have to multiply this by, I guess, 2, because a circle of radius 1 would be here, and this point would be root 2 over 2. And so I guess this is just the point root 2 comma root 2. Okay? And so then, you know, the sector of the circle is this, right here. Okay. So let's just label some of these. Like this green part is the line x equals 0. No, it's not. Okay, y equals 0. The height y is 0. And then this part right here has equation x squared plus y squared equals, okay, well, square this and square that, you get 2 plus 2. So it has to be 4, right? Because 2 squared is 4. So here's the equation. And then finally, this piece right here has equation y equals x. Okay. And so we need to integrate over this region that I'm shading in gray. Okay. And in order to do that, we're going to encounter some difficulties. But first, let's just begin as usual. So if I fix x and integrate the y dimension, right? I can integrate in one dimension. Then my formula is going to start with y equals something to y equals something. Now, looking over here, if I fix an x, I'm going to go like that, and I'm going to slide around. And if I fix different x's, notice that the bottom endpoint is always on that green line, y equals 0. And so this part is a 0. Now, what about the top? Well, the top endpoint, you see that sometimes it's on the pink, y equals x. So I'm tempted to write x there. But other times it's on the blue, which has a completely different y equals. It would be y equals square root of 4 minus x squared. So what do I write? Well, then I realized that I could actually split my integral into two integrals. So let me just first do that. And I'll say it in words. But the top y endpoint needs to have two different formulas. So we will split the integral. And what do I mean? Now I'll go to formulas. The integral over the sector S of the circle of the function f is equal to, well, first integrate over one piece and then integrate over a second piece. And my first piece will be this triangle, and my second piece will be this sort of almost triangle, but one of its sides is this blue curve. Okay, so I just split S into two pieces, and I integrate over both. And now I see that like my first integral will start with y goes from 0 to y equals x, because that's the green to the pink. And then my second integral will start from y equals 0 and go to y equals square root of 4 minus x squared, which is the green to the blue. Okay. And so that's how I'll at least start. And now what I have to do, well, once we have integrated away the y dimension, this is the up or down y dimension, when it's gone, what we will have is a function just of x. And I guess this is root 2, and this is 2. I'm sort of just projecting. Project to the x dimension alone. And so in my picture, what I see is that my green line is staying here, and this is where x is going to vary. And so in words, I'll say the second integral over the x dimension goes from 0 to the root 2 to 2, right? So it says like this piece, and then it has that piece. And so this is how the formula will then go, I guess, here will go from x equals 0 to x equals root 2, whereas from root 2 to 2 will go x equals root 2 all the way up to x equals 2. And so that's this piece here. And so now I can put it all together and say that this formula becomes, well, first we integrate with respect to y equals 0 to y equals x, and then we integrate with respect to x equals 0 to x equals root 2. That was the first piece that I called S1, namely this triangle here on that side. And we'll integrate f. Then we'll add to it. We'll add the second piece. And the second piece integrates first y from 0 to y equals square root of 4 minus x squared. And then integrates x from root 2 to x equals 2. So really try to understand how I split this region into pieces. And sort of one piece lies above this portion of x, and it's a triangle. It has the pink, so sort of the pink, the top is pink for this piece. And then over here, well, I better not choose pink, maybe I'll choose yellow. No, why don't I choose? Okay, so look, pink, and then this one had a blue top point. So this top is blue. And those are my two pieces. There's the blue piece right here. And here is the pink piece right here. And I guess I need, if they actually gave us, they didn't say what f was, but if they told us an f, that's what we would put there. And this is the integral. Okay. So then I'll say in words that this is the answer for, well, which one? We're going to integrate y first and then x for dy dx. Okay. And then what about the other way? So let's draw our picture again. So here's the radius 2. Here's the line y equals x. And here is our region. And if we slice it the other way, if we fix y first, fix y, then we get a horizontal slice. And then when we project onto the x-axis, or not onto the x-axis, onto the y dimension, and we move y, then we see that y will go from y equals 0 to y equals root 2. Because remember, this was the point, root 2, and this was the point 2, 0, and this was the point 0, 0. Okay, and the equations of these curves are the same. This was x squared plus y squared equals 2. Oh wait, sorry, 4, right? I always get confused. You have to square it to get to a circle equation. And this is still y equals x. All the boundaries are the same. And this is still y equals 0. Right? And so now we can integrate the other way. So fixing y and integrating x first. Well, what does that give? I'll go to my formula. It goes first from x equals, well, okay, my left endpoint for, x is going in horizontal dimension, and it starts at x equals y. The pink up to the blue, right? And so then I need x equals, I'm integrating x, so x equals, well, I gotta solve for x. It's 4 minus y squared, square root. Okay. And so that's what I'll integrate. And then after that, I just do y equals 0 to y equals root 2. Right, and so once we've done this, you notice that it is far easier to integrate x first and then y. So this is sort of do the dx first there, and then do the dy, if you like this notation. It's way easier because there's only one integral. Whereas here, if we wanted to first integrate the y, we had to split up the region into 2 pieces. Okay, so fixing y and integrating x first, then integrating over y second. And this is this required 1 piece, whereas this required 2 pieces. So which way you slice, you can take the 2 dimensions and slice first y, then x, or you can do first x, then y, and one way might be easier. Okay, 2 pieces or 1 piece. That is it. Okay. Notice here, I actually, I really like these, like having 2 pictures, because when you project it down, like whatever you integrate over second, it's easier to see where it should go, and you're not confused by the curves anymore. Same thing here. First we go here, and then we're integrating y second, and so I sort of project the whole picture onto just the y dimension, so I can very easily see that the 2 numbers, y equals 0 and y equals root 2. Okay, here's another version of the same answer.